All right, section 7.2 is about solving equations with rational numbers. Rational numbers are numbers that can be written like fractions, right? So these are going to be equations that involve fractions and decimals. Now, decimals are no big deal, right? Because we can work with those. We can put those in our calculator fairly easily, and it's not going to really change how we solve a problem. Fractions, however, can sometimes be problematic because to add them together or subtract them, you need common denominators, and it can get kind of confusing. So rather than solving them that way, I'm going to give you a method that you can use to eliminate the fractions in the problem before you even start solving. Okay, so to do that, you're going to find the least common multiple of the denominators of the fractions in the problem first. The denominators are the numbers that are on the bottom. And I'm going to go ahead and show you how to do that right here. Now, I know what some of you are thinking. 3/4, 1/2, those are super easy fractions to convert to decimals. That's not always going to be the case. So let's pretend that they're not, right? You might have something that's like 1/3. 1/3 is a repeating decimal that you would be rounding if you converted it to a decimal. So that's not going to be a good thing to do because that's not going to give you an exact answer. So don't just assume that you can convert them to decimals and solve them. You could in this example, but we're going to use this example to show how to do this method instead. Okay, so the bottom numbers of the fractions is what I'm looking at, 4 and 2. And I'm finding the least common multiple of those numbers. So when I list multiples, it looks like this: 4, 8, 12, 16, and so on. 2, 4, 6, 8, 10, and so on. The least common multiple that these numbers have in common is 4. Okay. Now that I know that the least common multiple of these denominators is 4, I can go on to step 2. Step 2 says multiply both sides of the equation by the least common multiple. Remember, you must multiply all the terms by that number. Okay, so I'm going to multiply 3/4 x minus 18 by 4. And what I do to one side, I have to do to the other. So I also have to multiply the 1/2 x minus 4 by 4. So I'm multiplying everything by that least common multiple. What this is going to do is eliminate the fractions. Okay, so when you multiply a fraction by a whole number, you multiply that whole number by the top number and then divide by the bottom number. So 4 times 3 is 12, and 12 divided by 4 is 3. 4 times 3 is 12. 12 divided by 4 is 3. So 3/4 of 4 is 3. That makes sense, right? So this becomes 3x. I also have to multiply that 4 by the negative 18, which is negative 72. Now I'm multiplying the 4 by the 1/2 x. 4 times 1 is 4, divided by 2 is 2. We know half of 4 is 2, so that's 2x. And 4 times negative 4 is negative 16. and poof, your fractions are gone. This is an equal equation to this. It's just that we got rid of the fractions. It's a really nice method for working with fractions that are challenging. Okay. Now I know how to solve this. I use my inverse operations and solve like normal. So I'm going to start by combining the terms with the variables. I'll go ahead and subtract the 2x from this side and this side. And I'm left with 1x, or x, minus 72 equals negative 16. And then I'll cancel out the minus 72 by adding 72 to both sides. And I'm left with 1x equals negative 16 plus 72 is 56. And I don't have a coefficient of x that I need to divide by, so that's my answer. All right, moving on to example 2. This is a word problem, and I see it's got some decimals in here. Logan has 2 aquariums. One aquarium contains 1.3 cubic feet of water. The other aquarium contains 1.9 cubic feet of water. The water in the larger aquarium weighs 37.44 pounds more than the water in the small aquarium. Write the equation with a variable on both sides to represent the situation, and then find the weight of 1 cubic foot of water. Okay, so I have 1.3 cubic feet of water in one aquarium and 1.9 cubic feet of water in the other. The water in the bigger one weighs 37.44 pounds more than the water in the smaller one. So the bigger one is the one that contains the 1.9 cubic feet of water, right? We're trying to find the weight of 1 cubic foot of water. That's my value of x. So when I write my equation, I'm going to have 1.9 times the weight of 1 cubic foot to equal the total weight of the larger aquarium. On the other side, the smaller one is 1.3 times the weight of 1 cubic foot plus the 37.44 pounds. You might be wondering, why is that on the side with the smaller aquarium? Well, it's because the water in the larger aquarium weighs 37.44 pounds more than the water in the small one. So when it says weighs, it's saying this is equal to this plus this much. You could also write it as the smaller one equals the bigger one minus the 37.44 pounds, whatever makes more sense to you. But now we have this multi-step equation to solve. So I'm going to cancel out the 1.3x by subtracting 1.3x from both sides. This leaves me with 0.6x over here and 37.44 44 over here. And I'm going to divide both sides by 0.6 to get my value of x, which equals 62.4 pounds. So this represents the weight of a cubic foot of water. Oops, sorry, you couldn't quite see that. So 62.4 pounds is the weight of a cubic foot of water.